Hello friends, today we are going to discuss regarding technique to increase output resistance of current sink. Now previously we came to know the NMOS used as a current sink. Now how can we increase the output resistance? Now in this figure, this is a current sink with source degeneration. Source degeneration when there is a resistor across the source and ground terminal, then this resistor gives a degeneration negative feedback degenerative. So current sink with source degeneration. This is a current sink and MOS is having a degeneration, source degeneration. Now this is the equivalent circuit of this current sink with source degeneration. Now how can we increase the output resistance? If we use a resistor, put a resistor across the source terminal, source and ground terminal, then this resistor will come with the transistor output resistance. Transistor output resistance. This resistance which we are connecting with the source terminal will come with the transistor output resistance. Let's see how this is increasing the output resistance. Now to find out the output resistance, we have to analyze the AC equivalent circuits. This is a AC equivalent circuit where we can see that this ground is connected to this gate terminal is connected to ground. Now during AC analysis, we short to ground for DC supply, DC independent DC supply. So this gate terminal is connected to ground. Now this MOSFET is represented with a dependent current source and output RDS, the resistance between the drain and source, and across source there is a resistor RS, so RS is connected to ground. What about this part? When there is a resistor across the source terminal, now source terminal is not directly connected to ground, so there is a potential drop across RS which will give a potential across the body terminal. So if we put a body bias, then due to body biasing, the current output current will change, so that this VBS is the potential difference between base and body and source, potential difference between body and source. So this term is coming due to this RS, where a potential Vx is actually dropping. So due to that, there is a body effect will come across. So this, due to body effect, there is a dependent current source is represented by VBS. Now let's analyze this circuit. Now if we apply a KVL in this part, then this output current I out is actually passing through this terminal, this branch and this branch. So I out actually the summation of this and this, and this I out actually passing through this RS. So we can write I out equals to Vx by RS. Okay, and this I out equals to also the current summation of this branch current and this branch current. So this is equals to gm vgs plus the current passing through rds is, this is the output current, drain terminal and ground terminal. Potential difference between the drain terminal and ground is V out. So how much potential will drop across here? The total potential drop is V out minus Vx that will drop across here. This V out minus Vx by RDS. So total potential drop between drain and gate is V out, and potential drop across this terminal is Vx. So V out minus Vx, that will be the potential drop across this terminal and this terminal. That is the same potential drop across these two terminal. These are in parallel. So the current passing through RDS is V out minus Vx by RDS. Okay. Plus the current passing through this branch GMB VBS. Okay. Okay. So now you can see that the gate is connected to ground and S is connected, with source is connected with a resistor. So the potential drop between gate and source is not the same as the potential difference between gate and the ground terminal. So here we can write VGS equals to minus Vx, because this drop Vx, this terminal is positive, this is negative. So potential drop across here Vx is actually, this terminal is grounded. So this VGS, potential drop between the gate and source, is the opposite polarity of Vx. Okay. Now also Vx equals to what? Vs equals to the potential difference between V substrate and body, V source and body. Okay. Now if we write V in this VBS, body source, here the potential is VBS, the potential difference between body and source. So if we change, then it will be negative VBS. Okay. Now also Vx equals to what? Vx equals to the current passing through this RS terminal into the RS. So I out into RS. Okay. Now if we put those in this equation, then we can write Vx equals to what? I out into Rs. So we can write I out into Rs by Rs equals to Gm VGS is actually minus Vx. So you can write minus Vx equals to I out into Rs plus V out minus Vx is I out into Rs by RDS. plus GMB into VPS equals to what? VPS equals to minus Vx, that is minus I out Rs. So now if we now simplify this part, then we'll get I out, Rs will cancel out, I out equals to minus Gm I out Rs plus V out by Rds minus I out Rs by Rds minus I out GMB Rs. So from there, if we simplify this part, then we can write R out equals to what? V out by I out equals to, now if I take the V out and I out in by I out, then we can simplify and finally we can write R ds plus Rs into 1 plus Rds into Gm plus Gmb. Okay. Finally we'll get this equation. If we simplify this part, and then finally we'll get V out by I out equals to Rds plus Rs into 1 plus Rds into Gm plus Gmb. Okay. Now point is that here Rds into Gm plus Gmb is very greater than 1. So we can neglect this one. So finally we can write R out equals to Rds plus Rds Rs into Gm plus Gmb. Okay, so that means Rds into 1 plus Rs into Gm plus Gmb. So from here we can see that the output resistance is increased by a factor of, so output resistance R out is increased by a factor of 1 plus Rs into Gm plus Gmb. So R out is increased by the factor of this.